I'm Phil, and today we're going to have a look at another project for the M5Stack MIDI unit with the DIN connector. And that connector is going to be connected to a MIDI keyboard. Let's just have a revised look at this DIN unit. So this is what it looks like, and it can connect to both DIN in and out using a for the MIDI connections. And I've now used this for about 3 weeks, this hardware. And I've used it on various projects. Um, the one that I want to look at today are the MIDI in projects. And I've done this on the Core 2, the Core 3, and the Stick C. And it works on all of those. So the project I want to have a look at today is a Core 3. So let's have a look at the mind map for that. And I'll zoom up so you can see it a bit more clearly. And on my desktop, this is the arrangement. So I've got a MIDI keyboard on the right. My computer's in the middle. And on the left, I've got the arrangement for the M5Stack computer and its peripherals. So let's just go through those. So there's the Core S3. And I want to program the colors for the Boomwacker colors will go on both the Core S3 LCD, but also on this strip here, this RGB LED strip, and both will show the Boomwacker colors. Let's move down and see. There's a closer look at that. And you can see an example there. When I press the note D on the MIDI keyboard, it will show up with the Boomwacker colors and also announce that it is a D that's been selected on the keyboard. The keyboard already has the Boomwacker color code on its keys. Okay, so let's have a look at the overall objectives. And what I want to do is get MIDI notes input from the keyboard, and I want to decode the MIDI message that comes from the MIDI unit, and I'll be using the Core S3 computer to do that. And I'm going to play the note, will be on the audio amplifier and speaker, and I want to explore ways to show that decoded note using the Boomwackers color code. So let's have a look at some of the background to that. I need to understand a little bit about ASCII communications because that's what's coming to me in that MIDI protocol. So that's one thing. And I want to show, let's have, well, when we decode it, the major algorithm for the MIDI value, I'm going to have a modulo value and the remainder of dividing it by 12 because there are 12 notes in the C major scale. And I'm mainly interested in the remainder. Then I'm going to map that remainder onto the colors. So background wise, we also need to understand the MIDI notes and the code for that. So what we're going to do is map that onto the Boomwacker colors. And there we have it there. That's the Boomwacker colors. And we then move on to have a look at how we can draw those colors using APIs in C++ for the Core S3 computer. So I'm using the native language or the native library there, and we'll have a look at that in a minute. So as an example of the colors, if we pick, say, red, we need to use either the description for red, or we could use the hexadecimal or the numerical breakdown for the RGB, which is shown on the left there. And Looking at the components that I'm using on the hardware, I'm going to use the Core 3, and that's what it looks like, but it will also have a DIN bottom uh, so that I can access the additional ports, both C and B. But I can only, without that DIN bottom, I can only get port A. I'll be adding the MIDI unit and the RGB strip. The actual RGB strip that I'm using is a waterproof one. And here are some of the uh, specs, and this is what it looks like. I'm using the simplest one, only 30 LEDs. Okay, so together with cables and the Windows PC, for audio, I'm using an amp and a speaker. And the keyboard, here's my MIDI keyboard. Connection-wise, this is what it looks like. And we might go across and have a look at that now. In the hardware construction, it's just a matter of putting the modules together. So we start off with a M5Stack CoreS3 computer, and that has a DIN bottom. And we need that to access two additional ports. And we connect the Core S3 is connected to a Windows PC where we do the programming in the Arduino IDE. And we add to that the port B, the digital RGB LED strip. And you can use this one or the waterproof one. So I've actually used the waterproof one, but they're both programmed in the same way. And then on port C, we add the M5Stack MIDI unit. And we connect to that a audio amp and speaker with the DIN plugs. And we also add the MIDI cable to a MIDI keyboard. And that's everything on our Boomwackers MIDI Core 3 arrangement. For software, we're using the Arduino IDE with libraries, and I got both of these from M5Stack. So we're using this native language here or this native library for our M5 Core S3, and for the MIDI unit, here's our library. And we need to assign the ports, both for the MIDI and for the RGB. So we might actually go across and have a look at that now. Let's have a look at the Arduino program for the Boomwackers MIDI unit. So what we've got here is a comments right at the beginning of the program and showing the hardware which is used, and that's covered elsewhere. And the objective here for this software is to show the Boomwacker colors for MIDI notes on the Core S3 LCD. And these are the colors that I want to show. So for many of them, you can just use, you can leave out the TFT underscore, but you do need it for if you want to get the dark sin and pink. Right at the beginning, we call up our libraries, and you'll notice for the RGB LEDs, we're using the Adafruit NeoPixel library, and the M5 underscore SAM 2695 is used for our MIDI unit. And we assign pin 9, which is the port B, the black colored one, for the RGB LED strip. And we let the software know that we've got 30 LEDs in that strip. So you can get other strips which have much more, up to about 130. You can then assign a different number to that. Then we call up the Adafruit NeoPixel library, and we assign an instance with our pin number to pixels. Then to MIDI, we set up a instance of the MIDI, and the rest of it is just some MIDI notes and the reduced notes and the MIDI velocity. In setup, we have a welcome screen which says Boomwackers MIDI, and this is how we set the different colors for that welcome message. And we're also setting up the MIDI on a serial port, which is the blue one this time, port C on the CoreS3, and we're using 18 and 17 for that. There are other possibilities, and we also set the MIDI instrument. So when we show a color, depending on the case, so for red in Boomwackers, we want to show red, and this is how we do it on the CoreS3 LCD. And we're also showing the note, which is a C, and we're using a text command for that. And that's followed on with the pixel control for the RGB. And you can see we're setting up 255, 0, and 0, and that gives us a bright red color. Then we go through all of the Boomwacker colors from D, E, and that's similar, but we do change the color parameters as we go through all that. And right at the end, or the loop, the continuous loop, if there is on the serial port to our MIDI unit, we then count the MIDI bytes, and if it's 2, we assign that to MIDI data, and if it's or to a MIDI note, and the MIDI data is assigned to a MIDI velocity, if it's the 3rd byte. If we get a 0, we then go and show the colors. And that's the software for the Boomwackers MIDI unit. So I got good results. I was able to show the colors on both the Core 3. I was able to also show the colors on the RGB LED strip. So that went quite well. And the notes that came from the keyboard, they were mapped onto those colors. But I was also able to get the and decode the MIDI protocol over the serial line and show that on the Arduino serial monitor. So all of that went quite well. The only issues were that the color rendering on both the CoreS3 LCD and the RGB LED didn't quite match the Boomwacker colors for some. Particularly the orange was very close to yellow, and also I didn't really get a good rendering for pink. Okay, so project went quite well, and for references, go across to the M5Stack. We might go across and have a look at that now on the shop. So there's the MIDI unit, and it's still available if you want to get it. We'll go back to our mind map. There's also a wiki for that MIDI unit. We go across and have a look at that. A little bit of detail there, not a lot. And while you can get some information on software, there's not much, and there's no user applications yet for it. We'll go back to our mind map. And here are some of the other references. If you're interested in Boomwackers, you can go across to their website, And that's all for me, but stay tuned and I'll give you a desktop demonstration. Here we have the M5Stack MIDI configured for the Boomwackers. So Boomwackers is the color code that represents the scale on the piano keyboard. So when we look at C, D, E, all the way through, we use a color code. And this demonstration brings in the MIDI notes on the DIN connector to a MIDI unit, which is from M5Stack, and it's driven by a stick C computer, also from M5Stack. And what we do, we go back and we play C, and we get C on the keyboard. We'll go through the scales, and the colours we get correspond to the Boomwacker colours. And that's the Boomwackers MIDI using M5Stack components. Here we're demonstrating the use of RGB LEDs on the CoreS3. This is the Boomwackers MIDI using a MIDI keyboard, which already has the Boomwacker color code on the stickers, but also we have a DIN connection for MIDI, and that goes over to a M5Stack CoreS3 computer. And we also have a MIDI unit connected and an RGB LED light strip. So the way it operates is that the notes on the keyboard, so when we press C, we get C on the LEDs and also on the CoreS3 LED. And we'll also get messages on our serial monitor. So I'm going to press E. So E, you can see, is yellow, and we get a message over here that decomposes the MIDI packet, and we also get the message over here. And we can go right through the scales. So go back to C, D, E, F, G, A, B, and back to C. And that's the MIDI Boomwackers on the CoreS3 and MIDI unit.